Okay, so we continue with our lesson. B, remember we're from looking at more to more calculations, and now we go to more to mass calculations. In the previous examples, we were given the number of moles and then asked to calculate the number of moles again. But here, we are given the number of moles and then we're going to be asked to calculate the mass. So, mole to mass now. We're saying, example 1, what mass of hydrogen can be produced by reacting 6 moles of aluminium with hydrochloric acid? So, what mass of what? Hydrogen can be produced. Where is the hydrogen that has been produced? It's here. So they want the mass that can be produced there now. Now, step number 1, don't forget, you always balance the equation. Always balance the equation. So let us balance the equation. How many atoms of aluminium? 1. Aluminium, 1. Hydrogen, 1. Hydrogen, 2. Okay? So we'd have to put a 2 there. Now, if we put a 2 there, chlorine would become 2, but this side chlorine is 3. So where would we put the 3? Okay. Similarly, we cannot put a 3 here again. We cannot put a 3 because we're going to say hydrogen is 3. But this side, how can we make hydrogen 3? So we can raise this chlorine here. We make it 6. How do we make it 6? We put a 2 there, such that 2 times 3, chlorine yankala 6. You've seen that, right? We have chlorine 6. And then, because chlorine is 6, we can just put a 6 there as well. 6 times 1, chlorine 6 this side. But then hydrogen has been disturbed. Hydrogen is 6 also. So how do we make that hydrogen 6? We put a 3 there like that. Okay? Aluminium 1, aluminium is 2 there, so we put a 2 there as well. Okay. Now, I'll make a video on balancing equations for those of us that are still struggling with this. So, from there we can write our mole ratio. So now what is going to be the mole ratio? Now the mole ratio, what balancing figure do we have here? 2. So we say 2 moles. So we say 2 moles. Then what balancing figure is here? 6. So we say 6. There we have a 2. So we say 2 moles. There we have a 3. So we say 3 moles. Now read the question with me. What mass of hydrogen, they want a mass of hydrogen, can be produced by reacting 6 moles of aluminium? So we have the number of moles of aluminium, and then they want us to find the mass of hydrogen. So what are their mole ratios? 2 to 3. The mole ratio is 2 to 3. How many moles of aluminium have been given? We have 6 moles of aluminium. So here where there's aluminium, we say 6 moles. And then this side we say X moles of hydrogen. And then we cross multiply. So 2 times X, we get 2X. 6 times 3, we get 18. And then from there, we divide both sides by 2 like that. So X will be equal to 9. Now this X, we are calculating for what? We are calculating for the number of moles of hydrogen. So now the question is, why are we calculating for the number of moles of hydrogen when the question is saying what mass? They want the mass. Now remember, number of moles, N, is equal to the mass given over the molar mass. So do we have number of moles of hydrogen? Yes, we do. We have 9 moles of hydrogen there like that. Equals the mass of hydrogen that we are looking for over, in this case, what is going to be the molar mass of hydrogen? Now when you go to the periodic table, on top of hydrogen there's 1. So you say 1 times 2, you get 2. So the molar mass is 2. So here we say 2 grams per mole. And then from there we're going to cross multiply like that. So m times 1, we get m, which is the mass of hydrogen, equals 9 times 2, we get 18. So 18 grams of hydrogen will be produced in this case. Let's go to the next one, question 2. Now, question 2, they are saying, how many grams of oxygen? Where is oxygen? It is here. How many grams of oxygen are required to react with 0.3 moles of aluminium? How many grams? Its mass. So what mass of oxygen is required to react with 0.3 moles of aluminium? As usual, you can pause the video, attempt the question, and then prove yourself right. So step number 1, what have I said? We balance the equation. Always, don't forget, we always balance the equation. Aluminium 1, aluminium 2. So not balanced, we put a 2 there. Okay? Oxygen 2, oxygen 3. Now we cannot change that to become a 3. No, you don't deal with those numbers that are down there. So what we can do is that we can raise those atoms, those number of atoms of oxygen from 3, we make them even, we turn them to an even number. Say we put a 2 there. When we say 2 times 3, it becomes 6 atoms of oxygen. So because we've got 6 oxygens here, we can just put a 3 there such that these 2 will become 6. Now, notice that by putting a 2 there, we have disturbed aluminium. Say 2 times 2, 4. So we get rid of this 2, and then we put 4 there. It is now balanced. Aluminium 4, 2 times 2, 4 aluminium. Oxygen 6, 2 times 3, 6 oxygen. Balanced. From there, we write the mole ratio. So aluminium, say 4 moles. Oxygen, 3 moles. Aluminium oxide, 2 moles. How many grams of oxygen? They want the grams of oxygen are required to react with 0.3 moles of aluminium. So this is between aluminium and oxygen, because they've given us the number of moles of aluminium and then they want us to calculate the mass of oxygen. So we are going to use aluminium because they want to pass a number of moles of aluminium. So aluminium and oxygen like that. What are their mole ratios? 4 to 3. 4 to 3. How many moles of aluminium have been given? 0.3 moles of aluminium. So where there is aluminium, we put 0.3 moles. Then this side we say X moles. X moles. So we are calculating, first of all, step number 1, we are calculating for the number of moles of oxygen. So from here, we are going to cross multiply. 4 times X, we get 4X equals 0.3 times 3, should be 0.9. And then from there, we divide both sides by 4. Now, when we divide 9 by 4, 9 divided by 4, sorry, 0.9. 0.9 divided by 4. Because remember here, both sides are going to divide by 4 like that for us to solve for x. So these guys will cancel. So x will be equal to 0.23. So we have 0.23 moles of oxygen. But then that is not the question. We've only calculated the number of moles of oxygen, but the question is asking us to calculate the mass of oxygen, because they've said how many grams of oxygen. Remember, grams, that is mass. Now remember that number of moles is equal to mass over the molar mass. Do we have the number of moles of oxygen? Yes, we have 0.23 moles of oxygen. So here where there is number of moles, we put 0.23 equals, what is the mass of oxygen? It is what we are looking for. And then we say over, now what is the molar mass of oxygen? O2. What is the molar mass? When you go to the periodic table, on top of oxygen, the relative atomic mass, you'll find 32 there. 32 times 2, you are going to get what? 64. So the molar mass is 64. So that 64, we are going to put it there like that, 64. And then we cross multiply. 1 times mass, mass equals, now 0.23 multiplied by 64, we are getting 14.72. So 14.72 grams will be the mass of oxygen. I hope you've understood. I'll send some work to the group. Let's have another example, a last example on mass to mass calculations now.